Started in just a few minutes. We're just gonna let the tubes fill up with everything. Say some hellos. Try to get my brain back. Why, I think I'm on demonstration mode. There we go. So drop in the chat, say hello. We're good going in just a second. Hello, Beata. Thanks for stopping by. I know DCD already pinged me. Hello, Tyeth from the big tube. Thank you for filing that issue, Tyeth. I mean to fix it, and I think I might have fixed it already in my current BLE work, but I'm kind of stuck. I'll talk about that, but I don't really want to work on it anymore. I'll try it next week. Hello, Brian Green from X. We'll get started in 1 more minute after we get a few more folks. Hi to Shippu. Hopefully you got your things working that you were working on. All right. Oh, I have this. Oh, I did pause it. Perfect. I realize you can't see my screen. I'm just adjusting my off-screen browser. All right, it's 2 o'clock. I hear you, Brian. Great. I'm glad it's working. Seems like it's working. Hello, everybody. My name is Scott. I work for Adafruit on CircuitPython. CircuitPython is a version of Python designed for microcontrollers. If you don't know, microcontrollers are little, tiny, inexpensive computers. Here's a teeny tiny, this is called a printed circuit board. This chip here is an RP2040, which is one of the microcontrollers that we run CircuitPython on. This is a board designed by Adafruit, who I work for. This is called a Cutie Pie, a nice little tiny small form factor. So kind of I work on the software side to support the hardware sales of Adafruit. If you want to support me, you can do that by going to adafruit.com and purchasing hardware there. If you want to join our chats that last longer than this stream, that we have a Discord server, you can go to the URL adafru.it/discord. This is a deep dive. I do these usually 2 p.m. Pacific here on the Adafruit streams. Next week will be Tim. I am camping next weekend. So Tim will be filling in for me next weekend. Preemptive thanks to Tim for filling in when I'm unable to do it. Yeah, it's usually 2 hours. I love taking questions and going off on tangents. I go off on tangents even when there aren't questions. So if you have questions about embedded software, CircuitPython, embedded electronics, I am game to try to answer them. Just to kind of tell you my plan is, in the title I have ESP32-C6 low power. One thing I realized I haven't done, I don't think I've done it on the stream, is actually like using the PPK2 from Nordic to monitor the power use of something. Yesterday I redid some of the pin alarming on the ESP port, so I want to try that and see if it works. That's to enable the C series of chips, and basically I think I covered all of them. So I want to test that. That's something I haven't shown on the stream. That's kind of my main thing I have planned, and then depending on how that goes, then we'll do some other stuff. So I had asked Shippu about some parallel display stuff, and they say that it looks all correct on the logic analyzer and works on the RP2040, so I'm out of ideas. Ooh, that's tough. Yeah, logic analyzer looking correct is definitely where I would go. DCD says the timecodes on YouTube are showing negative numbers. Maybe something changed on YouTube. DJ Devin says it does as well. I'm not looking at that, so I'm not sure. Hopefully they're still correct. I think I did start slightly before when I was supposed to start, so maybe that's it. DJ Devon3 says it's 92 here, sweating while sitting in the workshop watching your stream. Thank you. I hope you can find a place that's a little cooler. It is kind of, it's 79 in here as well, so I have the fan on high. It's supposed to be like 70 something outside, so the fan's not helping me too much. But for now, I'll skip the AC because it's even noisier than the fan. I have shorts on, so I'm in not too bad a shape. Although my brain is quite out of it. I've had a busy week. Yesterday I was at the car dealership getting the car detailed and tuned up, and I do pick up a drop off for Ari, my son, Tuesday, Wednesday, Thursday, and like they got me the car at the very last minute. I got to daycare at the last the last time. So it was very nerve-wracking, and so yeah. Sabrina says, watching your stream here in Seattle while building some robots. Thanks for doing this. Awesome. What are you building robots out of, and where in Seattle? Because I am actually in Seattle as well. I don't know if I said that or not, but I'm in Ballard. You can see the window cam up here. We're looking out, kind of Ballard Bridge is just behind that tree. Cool. Building some robots. I think I've decided to build some Lego after the stream. I've been like, I talked about it last week too, and I think I'm just gonna go buy a set and build it tonight because that's what I'm feeling like. I need that to get off the computer and do something. Okay, so 3D printing the shells. I'm on Queen Anne. Oh, I could probably see you. I'll wave. Hello, Queen Anne. Queen Anne is like the left of this window picture here. And then depending on timing, depending on how deep sleep stuff goes, you know, I've had these other things like the stemma G0 stuff going and the language server replay stuff, so code completion, and I want to run that against the open source LLMs. I've been kind of poking that. And then another thing I started is actually a Feather IMX RT1060. I've been doing so much software that I think my brain's like, let's do some hardware. So yeah, I'm pretty scattered. I don't know if I mentioned it last week, but Ari, my son, he's like 2 something. He hit this milestone where he can now wake up in the middle of the night and come into our room. And so a lot of nights this week he's come in and gotten us up in the middle of the night. So I'm a little out of that as well. Okay, so I think before I do low power, I can talk about BLE as well, because I've been trying to get BLE fixed up, but I kind of hit a wall with that, and I need fresh eyes next week. So let me answer questions. I said in the comments, and I'm happy to answer any questions folks have. So DCD knew I was gonna stream and ask some detailed stuff. So let's start with that first. We make companion robots. Nice. We have a hardware happy hour here in Seattle as well. It was last night and I missed it. But if you're into hardware robot stuff, the hardware happy hour is on Meetup, and it's every first Thursday of the month, and it alternates between in Fremont Brewing usually, and Postdoc Brewing. That's super cool though. Missed some stuff about the language model you're working on. That sounds different. I'm not building a language model. I'm just, that's awesome you've been there. Hopefully I've met you. Although I've been missing it a lot because I had the kit. The language model stuff is just, I'm really started liking GitHub Copilot, and I want to compare the results of GitHub Copilot to the results of the open source models that do code completion. So what I do is I have some recordings of the queries and responses from GitHub Copilot as I've been just working on stuff, and I want to replay those towards the open models and see what they come up with. Okay, so DCD says some questions / topics. While looking for ARM toolchains, I noticed Tannewt had a GitHub action for the GNU toolchain. How did a particular version get chosen and installed? Did you build from source or select from a distribution? I don't know what you mean by Tannewt. Probably one of my repos. But there's somebody else has created an ARM GCC toolchain. So there's a couple. So personally, I run Arch Linux, and Arch Linux has its own build of ARM GCC. So let's go to the desktop. Have you used any Octo AI models? I have not. Also, Llama 3's work great for what we're doing. No, I'm just embarking on the local LLM stuff. I forked someone's repo. Oh, okay. So I was probably just updating it then. That's probably what you're thinking of. ARM. Yeah, this one. You're looking at this one. Yeah, so Carlos has the one that we actually use. The fork was just from me updating it to the latest release. If you need any help, reach out. Okay. I'll have to... Sabrina, if you could add me on LinkedIn so we can connect. Scott Shawcroft on LinkedIn. Oh. I think I know, yes. I know, yes. I know your partner. I'm thinking of your partner, I think. Yes, cool. Well, thanks for joining. Okay, so this is an ARM GNU toolchain GitHub action. The fork was just because I updated it. That was the day where I was like, I'm having this problem. It would be nice if they had released the newer version, and I went to check the source thing, and they had just released it. So, so this is what we use for GitHub Actions. Personally, I use Arch. So Arch Linux has its own version of arm-none-eabi-gcc. So it's actually, I'm usually locally working ahead of where we are in the CI. The CI uses this, and this version is not quite straight from the from ARM. So yeah, you can see here that this is like, let me see if I have, yeah, so this is what that is from. Let me see if I can find the upstream page. So like ARM likes to be able to patch it potentially. ARM GNU toolchain. I don't know, they've moved this page. Right, so this is the latest release. So this is from the October one that I've updated. So this is pre-built toolchain. So the thing with GCC is that it's only for, GCC is only built with one target in mind. Packrat, yes. Yes, 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 cool. Yeah. Now I'm piecing it all together. I'm glad you're watching. Thanks. So yeah, GCC needs to be built with a particular target in mind. So ARM has a few patches on top of theirs. So they lag behind what GCC releases. And Arch doesn't use the ARM source. Add us. Okay. All right, I'll try to remember. My email's scott@adafruit.com too. There's an AI kit for Raspberry Pi. Yeah, I looked at that a little bit because I've been thinking about wanting to accelerate locally as well. Basically splurging on a fancy GPU maybe. But what I've decided is that you could run the models slowly without fancy hardware. So like if they're garbage, like if the results they produce are nowhere near what Copilot can do, then I'll just use Copilot. Okay, so for tool chains, we usually use arm-none-eabi-gcc. This is saying you're on ARM with no OS, basically. And then because I use Arch Linux and they have this version that is actually keeping current with what GCC releases, I tend to work ahead of what the CI does, which is usually this one. And we use the action to install that one. Finally, a reason for the dual PCI Pimoroni hat, dual AI acceleration. Yeah, I mean, I'm curious. Like running the LLMs. I think one thing that I was having trouble with is like the models are really big. So I don't know exactly how that AI accelerator handles the fact that like you don't have a ton of RAM. Which is why I'm still kind of torn between like, do I just make sure that I'm on the like current CPU architecture? Because like RAM's not that pricey, relatively pricey, versus like GPUs cap out at 24 gigs for the consumer side. And if I upgraded CPU, then that would like benefit all of the work I'm doing, not just acceleration. Basically compiles would go faster with a newer CPU. Okay, anyway, so I think that was one piece of DCD's question. What version do I use on personal devices and what do I use in CircuitPython? Generally, most people are not running Arch, and so they use the ARM version. The ARM version is kind of like the default one. Me working ahead just means that I may like have different code size coming out of it, or like different errors and stuff that happen. It just works ahead. In fact, GCC 14 introduces this like stronger code optimization, and that code optimization leads to exceptions not working. So like Python exceptions don't work in GCC 14 before I found a fix that had already been upstreamed to MicroPython and pulled it down into CircuitPython. So CircuitPython works with GCC 14 now, but it didn't before. How does CP builds deal with path order to ensure the right tools are selected? It doesn't really deal with it. It assumes that you have arm-none-GCC installed in your path. It doesn't expect you to have more than one. And then for the stem-g0 stuff, so Clang is different. Clang is an alternate C compiler based on the LLVM project. One thing about it is it's generally built to handle all different outputs. So you don't need a Clang arm or arm-none-clang or whatever. Instead, what you do is you do Clang and then --target arm-none-eabi. But the nice thing there is you don't need a separate binary usually. You just need Clang. Now that gets complicated and tricky because compilers usually ship with a libc pre-built libc and pre-built what Clang calls runtime stuff, but is the libgcc stuff for GCC. That makes it more complicated, which is why for the stem-g0 stuff and the build stuff I've been prototyping, I'm actually building Pico libc, which is one libc implementation. So instead of needing to worry about like fetching it for the specific target built, I just build the one I need. Has been my approach to that. DJ Devon3 says, I've yet to use Copilot, unsure how to even do that. So Copilot for me shows up in my, so here's, I've been working on BLE, but if I just start typing, these are, so, sorry, I'm pointing with my fingers. So this autocomplete here is autocomplete from Sublime Text and potentially Clang D. Oops. But what this one here with the accept reject is this is actually what GitHub Copilot has guessed that I'm going to want to do. And I use it a lot for exactly this, which is like reasonable debug prints. I found it really helpful. So I'm in Sublime Text, so there's LSP Copilot and Clang D plugins that I had to install. But if you use VS Code, there's a plugin that you could do for Copilot instead. It does cost money for some people, but I was kind of, they have free GitHub Copilot for open source developers. So, and they show this like conversational stuff, but I'm doing it more as fancy autocomplete. So it's 10 a year, but there's, I don't know, it's open. I'm getting it for free. Yeah, oh yeah, see, it's free for verified students, teachers, and maintainers of popular open source projects. I don't know how that, I don't remember how that got set up. I don't think I paid for it. But I am really curious about the local ones, because the local ones you could buy some hardware or run slowly on your own computer instead. That's part of the reason. And then the other reason I'm interested is just learning more about how it works. Anyway, I recommend it if you're able to get it for free. I would probably pay the $10 now, but only now that I kind of know how to use it. It's really good for guessing the next line of code that you're going to want to write. It's not always right, but enough times it's right that it's like pretty handy. And it's especially good if the next line of code you're going to write is not particularly, doesn't need to be exact, like for debug prints. It doesn't actually really matter what it is. I think once you're seen to merge something in a valued public open source repo, then they auto refund you. Yeah. Okay. DCD, did that answer your toolchain questions? In terms of versions of Clang, I follow either, well, I have desires to modify Clang in the future, so that'll follow whatever version they're working on. But generally, I'll just follow Arch Linux Clang version, or in CI land, I'd follow the Clang that is in the latest Ubuntu in CI, is my goal. But generally, I like the latest. I don't really want us on older versions. Okay, so let's switch gears and see if this code I wrote yesterday works. I don't know. One thing I should check is if we have an issue for it. Deep sleep. I don't think I've talked about deep sleep on the stream yet, so I'm thinking this is probably a good. Here we go. This is what I'm working on. Hey, Tyeth filed this issue. I would lovely to have deep sleep available on all chips that can support it. I'm running the ESP32-C6 from downloads. So when I had originally added the C6 support, I had, so anyone that uses your GitHub CI action CI gets the same binary. Yes, to answer questions. So don't use my GitHub action because that repo doesn't stay up to date. I only created it for the Carlos one. like to PR to the, use the Carlos one. That's the one that you should be using. Although right now they're the same because I updated it most recently. But the Carlos one is the one you want to use, not mine. And that's what CircuitPython should be set to. Okay, so let's talk sleep. A lot of this work was originally done for the magtag, which is an ESP32-S3 e-ink board that that Adafruit has sold. And the idea being that what you can do is you can wake up, fetch something from the web, update your ink screen, and then go down back to sleep into a deep sleep. CircuitPython has two different levels of sleep. It has a light sleep and a deep sleep. And the defining characteristic is that deep sleep will actually turn everything completely off, or almost everything off, and then restart CircuitPython kind of from the get-go and restart your code. Whereas light sleep will keep all of the state and kind of keep everything going. And in fact, on ESP, it doesn't really do anything. But on other boards, it may, like, if you can preserve RAM and start from where you left off, then you'll do that. But generally, if you're really concerned about battery power, you actually want to do deep sleep. And it's great for these, like, I want to update inks every so often, or take a measurement, a temperature sensor measurement, put it up to I/O, and then go back to sleep. So we originally had support for the ESP32, S2, and S3. They all kind of have similar things. Let me actually pull up. Let me do it off screen to make sure I don't show any of my personal stuff. But I was doing a spreadsheet yesterday, which I will show. So this is what I was doing yesterday when I was trying to wrap my brain around it. And in fact, let me move it into my many tabs. So Control Plus, make it bigger so you can try to see it. So here's the chips that are currently in the ESP-IDF, and different features. So this is specific to pin alarm, because the reason that I turned it off for the C series is that the C series doesn't have this ext0 thing, which caused the compile not to work. So this is a question of, so I talked about the two types of sleep that we have in CircuitPython. Light sleep, where you can kind of go to sleep, but remember, like, everything keeps running, that if something's running in the background and you resume your code, you don't start your code from scratch. And then there's deep sleep, which is like you turn pretty much everything off, except for your alarms, and then you start back up from the beginning. But when you start up from the beginning, you can tell that you started up, that you were woken up, and what alarm woke you. So I mentioned this when I was thinking about the API that I wanted for deep sleep. I thought of this like, okay, you're asleep, how do you wake up? And so support is actually done through this alarm module. So you can, we have different types of alarms that you can set. And I don't know, do we have a learn guide for this? I think we do. Yeah, Dan wrote one. So deep sleep with CircuitPython, alarms and sleep, the two types of sleep, alarm module, time alarm, pin alarm, touch alarm. So this is exactly what I need, because I want to do some pin alarms, deep sleeps, to test that I got that working. So you can see that you do alarm, exit, and deep sleep until alarms. So you can give it one or more alarms at this point, and then you're done. Your code exits. Like, that's the reason we put the word exit in there, because any code below it won't run. You basically turn everything off, and then, well, you set an alarm, and then you go to sleep, and then the alarm will wake you up. So pin alarms are, you can set it whether it's high or low. You can also do edges, but edges are not always supported. Generally, it's just high and low state. So you'll have like an I2C sensor or a timer. It has a pin that says like, oh, after a certain amount of time, the pin goes from high to low. And then you detect when it goes low and it wakes you up. And there's a little piece of the circuitry on the ESP that will like trigger when that happens and wake everything up. So that's pin alarm. Touch alarm does the same thing, but for touch pins. And then time alarm just uses a clock of some sort to sleep for a given amount of, actually it's not for a given amount of time, it's at a particular time. So this is like you create a time alarm 20 seconds from now, and then it actually takes a little time to like go to sleep. And so that's why you give it like an absolute time of like, if you end up doing so much work that like your time alarm already goes off before you went to sleep, then you don't go to sleep at all. Is that clear as mud? This is an example that has both a time alarm and a touch alarm. So you can provide, into exit and deep sleep, you can give it more than one alarm. And then for completeness on these examples, for light sleep, it actually will, you just light sleep until alarms, and I think it returns the alarm that woke you up, but I'm not positive. So I haven't tested this on the C6 yet. So let's take, oh, and that's kind of annoying. I think it's on the Wi-Fi. Maybe not. Oh, it's waiting for download. Okay, so I have a bunch of debugging stuff. Let me just, I'm gonna do a non-debug build. Okay, so this will take a little while. So this is the UR output here. And we'll build a new board and load it. So the web page didn't load up because I wasn't on that. So generally what I want to do is I want to get the sample, the test code onto the device, and then unplug the device from USB. So the last kind of complicating factor for this is, okay, if you're deep sleeping and you want to turn everything off, including your Wi-Fi, including your USB, not in this case, but in other cases, like, how do you debug it if things turn off? So CircuitPython also has this idea of pretending to deep sleep. So if you have a workflow active, then you will, if you have a workflow active, it will pretend to sleep instead of actually sleeping. Now, this is going to be something we need to think through that I haven't thought through for the non-USB boards. Like if Wi-Fi is up and I call deep sleep, do I want to pretend or do I not want to pretend? So we're going to have to figure that out as well. Ty says, saw some talk of BLE advertisement packets still running in light sleep, but was Arduino ESP-IDF. I naively assumed that light sleep in the future may send Wi-Fi 6 keep alive and BLE adverts in CircuitPython. Yeah, so I think ESP light sleep doesn't actually call the IDFs light sleep. So they have a function called light sleep, but it turns Wi-Fi and BLE off. Instead, they also have this idea of modem light sleep. It's basically like if the core is not doing anything, it's gonna like use a little bit less power. And we basically idle CircuitPython for that amount of time. But it's really not going to be that much different. Okay. So let's see if we can deep sleep here. Am I connected? I like how it adds the S. Okay, so this is the web workflow. The C6 does not have native USB. So you need some way of talking to the device otherwise. And we don't actually have a way of creating a new device or a new file from here. What we can do is we can use the code editor. So this is a version of the editor that fetches a bunch of JavaScript from the web. So it doesn't work if you don't have Wi-Fi, but if you do have Wi-Fi, you could do fancier editing. So I'm going to do the pin alarm deep sleep, copy code, paste it here. NeoPixel doesn't have power, so we're going to delete that. Like I said, the magtag was the thing that we did first. Save as code.py, save and run. Oh, and we don't have the NeoPixel module. I'm actually just, I think I could load it, but I think I'm actually just going to delete it instead. Because I'm going to use the power monitor instead to monitor it. Once I get to the point where I think it's working. Oh, Control S works. Nice. All right, so it doesn't look like it worked. Might as well deep sleep between Wi-Fi 6 packets. I don't know. Or it disconnected. That's the other thing. I don't know if it's active or not. Can I? Oh, maybe it did deep sleep. D11. I have no idea. Okay, so maybe what we should do is, let's just try this. So let me do the overhead. Oh, I have the wrong. Oh, you know what? I forgot to add it back. I was having some tricky. Oh, there's a pipe wire capture. Should I try a new type of capture source? Oh, no, cancel. No, I don't want to do that. Not right now. Add existing hover cam. Okay. Order, move to bottom. All right, there we go. So you should be able to see my desk now in the bottom of my chair. So this is the Nordic PPK2, and let me switch this, and I will lock focus. Okay. All right, so what we have here is the Nordic PPK2. Unfortunately, we carry it, but it's out of stock. I looked, because if you're doing, like, we get people on the forums from time to time saying, like, my battery life isn't what I expected. Like, if you care about low power, you need a way to measure it, and this is a great, it's $100 from Adafruit, $90 from DigiKey. It's like very low, like, I got another power monitor thing for like $600. This is the way to go. This is only $100, and it works just great for what I'm doing. So what I want to do is, oh, I dropped it. So if you're doing low power, get yourself some way to measure it so that you can verify you're getting or not getting what you think you're getting. So what I'm going to do is I have these two leads. So the power, you can have it go in and then out here. Instead, I'm just using USB for power as well. And then I didn't bother looking for a blue wire, or a black wire. The blue wire is ground. The other ones, all the bits will be jumbled now. Yeah, because I dropped it. So PPK2 is really awesome. And then what I've got is just this, I have this like battery lead. So I'm just gonna plug it into the battery port of my feather. Now it didn't turn on because you can actually control from the program whether it's on or not. So if we go here, howdy from Elector, how's the family? Hi, Brian. Man, we have lots of folks on the Restream chat today. It's awesome. Sorry, we don't have the Restream chat on here exactly. Okay, there's bench cam. Let's turn bench cam off. Now we have hover cam, but it's too small, so let me make it bigger. So that you can maybe see what I'm doing. Okay, so to control the Nordic PPK2, you download their like NRF Connect app, and then it has apps inside of it, which is fine. I was gonna say confusing, but it's fine. So set the source, set the voltage. So this is 4 volts, right? We're going into a battery out, or we're putting power as if we're a battery. Batteries, LiPo batteries range from what, 3.4 to 4.2. So 4.0 is kind of a nice thing. And then I think we want to start, we don't need digital channels. So it actually has a small logic analyzer as well. We're not going to deal with that. And I think what I do is I hit start, and then I hit enable power. And we get this nice chart of power usage. So it looks like we did go to sleep. Okay, let's take a look at this. So this is even fancier than last time I used it. So this is startup. We can see that we're using, I don't know, 37 milliamps for a while. And I bet these 4 pulses are blinks, and then I bet this is Wi-Fi. If I had to guess, that's what's happening here. And I don't know what this is, but it might be light sleeps. One thing that we could do maybe is we could actually use the logic port to actually start to capture some like corresponding signals. So maybe the NeoPixel pin is not broken out, but we could add like pin twiddles on our side as well. But that's my guess. What's happening here is that this is maybe Wi-Fi light sleeps, modem light sleep. Although that's still 54, which is kind of a lot. I was going to ask how to coordinate the graph to locations in the code. It did cross my mind. You could actually capture like the UART output if you wanted to, but right now if I turn UART on, it's going to spit out a lot of stuff. The other thing that I need to try is, theoretically, it's actually sleeping right now on, what did I set it to? D11? D11 going low. So I'm going to put in this confusingly red wire. Actually, I have a black wire here. Let me use a black wire. So instead of doing a button, I'm just going to use a wire. But I'm going to add 1 to ground. And then D11 is, this is a prototype C3 feather, I think. So it might change. It's listed on the shop, but it's not available yet. But let's go back to our power meter. Actually, one thing, let's look at how low this is. Okay, so this is like pretty rough, but it's like 366 microamps. So that's like in theory our sleep current. So what if we start again? Yeah, don't ask again. Okay, so we're right there again. Let's see if I can wake us up. So I think it's, let's see, 13, 12, 11. Boom. Okay, so we are started up back up and we've slept. And now if I go into this one, I think it's this one. Yeah, see, so I triggered it again. So our deep sleep is working, it appears. And you can see there's a similar pattern of like, we get started. That's awesome. So we're at 370 microamps. The other thing that's interesting is like how long this takes, and I don't know if we can do, hold shift and left click and drag to make a selection. So let's do that. So it's 46, I don't think that's seconds. Oh, okay. Oh, interesting. So it was awake for 5 seconds. It had an average of 86 milliamps. I don't know why max is 0.77. That doesn't make sense. But it's actually like the amount of charge is the like power, I think. So that's quite good. Now the question is this how we want it to work? Do we want that to happen? Or is there a, how do we say I'm doing web workflow and I want to pretend to deep sleep? So like if you're on battery, or if you're on USB, you pretend to deep sleep. If you're on battery, you're not connected to USB, and therefore you, maybe it's a function of serial, the web serial. Does that make sense? So if you have, the scope tab is for, are you attaching trigger and marker pins? Scope tab. Oh. Well, I don't know. I've only ever used the data logger part. The mini map is new from last time I did it. That's just great. It's awesome. So this is like 365 microamps. And actually, I'm curious. Let's both look at here. So this guide has some power consumption numbers. And they recommend the PPK2. And you can kind of see the similar pattern here, right? So this says it's 227. Deep sleep power consumption. Oh, that was with time alarm. And then on S2, 230 for time alarm, 165 for milliamp, or 165 for pin alarm. So that's one thing that's nice. We could actually try a time alarm. Measure to be sure. And then I think other chip families, it looks like it was published. Deep Sleep. STM32. Deep Sleep at 700. SD card plugin takes a lot of power. NRF. NRF is generally quite good. I thought. 6 milliamps. Oh, that's a playground. That's because NeoPixels take like a milliamp a piece, even if they're off. So you got to be aware of your NeoPixels. 1.4 milliamps for the Pico. Time alarm is added at 7 milliamps. So I'm curious what time alarm is. But now the question is like, how do we get it back, actually? If we start up and go to deep sleep and that turns off web workflow, then what do we do? We could safe mode. That will get us back. But yeah, I wonder if it's the, like, if you're... The other way that the USB things works is, like, if you're deep sleeping and you plug USB in, it won't kind of enable the workflow again. But cool, so deep sleep pin working is working. It's just not, we don't know when to pretend to deep sleep. But the problem is that we don't really have, the state of like you're connected to edit the file system. We only have a notion of whether you're connected on the WebSocket. So maybe that's what we do, is just say like, hey, if you have a WebSocket, you're going to pretend to sleep instead of actually sleeping. I wonder how we do that. Okay, so a lot of this deep sleep mechanics actually, like the root of that stuff is actually in main. If we look for deep sleep, fake sleeping. So we're fake sleeping. True. Pretending to deep sleep. So supervisor workflow active is what it checks. And we're just doing it based on USB device. So let's test it with the serial connections, basically, because I think they have that state. CircuitPy web workflow, I think is what it is. And then we want to change this to if USB ready, return true. And then, do we have that, or is that making that up? So that's an interesting, that's a Copilot prompt, but I'm not sure. I think it's just being smart in the terms of like regurgitating the same thing. I'm not sure we actually like that. I'm not sure that function actually exists. So let's see what, yeah, see background status, start, stop, and then WebSocket says WebSocket connected. So that's what we want, is WebSocket connected. And that is part of supervisor shared web workflow WebSocket. Okay. So we still have this problem that we probably can't connect to the WebSocket fast enough. I bet it'll sleep still on us. But let's give it a shot anyway. Oh, our USB's not connected. So let's go back. Let's turn power off here. Unplug, because I don't want to have two things powering it at once. Plug it into USB. Starts up, and we can get into safe mode. That's probably, well. See, this is interesting too, because I think when you deep sleep, you do also turn off the USB to serial device. So let me just get into, that didn't get me into, oh, come on. I think I can get into safe mode. Am I not getting into safe mode here? Yeah. Let me do the actual. That's what I need. I actually held the boot button and pressed reset. We should actually make safe mode work too, if it doesn't. I have a lot of debug prints going on though. That's just kind of frustrating. So why isn't safe mode work? It's interesting, we are seeing it connect and disconnect. It's taking 16 seconds. This is the tricky thing. It's already down again. Come on, why isn't it? That should be in safe mode now. No, that's not what I want. Darn. So maybe, do I have a boot button set? How do I get safe mode working? C6, board defs, boot button. For entering safe mode, use the boot button. I tried that, and it doesn't work. All right, let's turn logging back on. So I'm gonna plug my UART back in. There's a separate boot thing there too. And then I'm going to, maybe I will sublime merge. I've got changes that I just don't want anymore. These partition changes things, all this logging stuff, I'm just gonna discard it. And then some other stuff that is fine. So let's do a clean and flash so that we can get some debug output. Let's fix safe mode. You need one of those newfangled USB isolators. Stop the 5 volts from PC and just rely on the PPK2 for power supplies measuring. Yeah, but anytime that you connect data pins, you still risk leaking data, which is tricky. Any questions? Is this interesting to folks? I feel like this is the first time I've seen it. I honestly didn't expect it to work. I am curious now to see if we do a time alarm. Well, one, that it works, and two, how much power it takes. And then what we could also do is actually, I only test built the C6, but I should be able to do it on all of the other chips. I should be able to enable alarm on everything. I did disable touch alarms because these don't have touch peripherals. Yeah, good to see the Nordic PPK at work. Yeah, it's so handy. And it helps boost my confidence that it just worked out of the box as well. But yeah, if you care about power, that's the thing to do. So one thing you'll notice is that when it wakes up from deep sleep, it doesn't do the safe mode blinks because it actually knows that it woke up in deep sleep. Markers to the power graph via toggle pins. Okay, let's do that. Let's try doing that too. So one thing we can do instead is we can use D13. Instead of doing new pixel, we could just do a LED on and off. Potentially multiple. Come on. Waiting for download. We don't need to do clean and flash because the build worked. My guess is the bulk of that 5 seconds is actually connecting to the Wi-Fi automatically, which actually, you know what? Maybe when you start up from a deep sleep, do we auto connect to Wi-Fi or do we not? And do we start up the, I want to say that DCD says, I didn't realize it had logic analysis support. I don't know if it has like protocol decoders. You've had an interest in SIGROC type loggers in the past. Any progress on that front, Scott? Yeah, it comes and goes. In the same way that the PPK2 really democratizes, like it makes it low cost to do power analysis. I always wanted to have low cost logic analyzer stuff, logic analysis too. Because CLEAs are really expensive, but they're super helpful. I would say no one's really done that yet, but it's actually, I would say, more of a software problem than a hardware problem. Because any hardware you make has to have good software support, and the SIGROC project has been quite unhealthy for a while. That's like the open source logic analyzer thing. And I kind of think that also, if you were to do it again, you'd probably want to be in browser. You probably want to do it in browser so that it's like more portable. And then you need like, how do you render the wave tracks and stuff? So I don't know, it's still on my radar, but I still end up using CLEAs because the hardware and software integration is good. And again, getting the higher speeds can be tricky too. Although like the IMX, the higher end IMXs have a lot of RAM and they have high speed USB, it might be the case. There's also a project to use the RP2040 and PIO to sample, which can be helpful too. Okay, we're staying in the bootloader. So let me try to do safe mode and see what happens. Oh, and we didn't get any output. Oh, did I do a... Darn it. I didn't do a debug build. All right. That's why I'm not getting an debug output. Let's figure out why safe mode doesn't work. First things first. Safe mode is meant for exactly this. Of like, I can't get it. I can't get my code back. Can't get back into my code. I did something that locks me out. What do people think in terms of like when to like do fake deep sleep versus real deep sleep? And if you're deep sleeping, do we auto connect to the Wi-Fi? I think we do, because you could always not use that and then do the manual connection from your code. Like there's a way around it. Because definitely people rely on that auto connect. But maybe we don't start the workflow up if we deep sleeped, which might save a little time. If we're coming up from deep sleep, because we don't expect you to be able to connect to it anyway. So like, why spend the time? That's the other nice thing about using the PPK2 is not only can you measure like the levels, but you can measure how long it is. Because it's usually, I think the wisdom is that when you're deep sleeping, that matters the most, because you generally will deep sleep for quite a long time. But like, you can also say, like, depending on how much power you spend like during that awake period, could be significant. So like if we go back to here, like that's one thing. So that selection that we did originally, this wake period, which has a little sleeps in it too, but it was 430 millicoulombs. I think that's what C is, columns or whatever. But if we move this, what was it, 430? So like this is 1 millicoulomb for that 4 seconds. So 4 seconds times 400 is equivalent power. I don't know. Auto-connect could be a configuration option when going to sleep. Does the app integrate power over time? Is that the average? I think it's not average. It's this this number here, the charge, I think is the like sum of the underneath the line, basically is what the charge is. I think that's what it is. Okay, so I mean that is quite good for pin wake. We're in the bootloader, so let's do this. Oop, did I press it at the right time? So we still started a Wi-Fi. There's some other BLE related debug prints in here. And it's warning about the I2C thing, which we do need to. So let's just take a look at safe mode. Let's fix safe mode first. Safe mode. Wait for safe mode reset. Okay, here's where I really like Copilot. ESP, that's not right. ESP log static. Filling that out is really nice. Okay. So here's where we skip. This is what causes us to skip the safe mode wait if we're in deep sleep. I don't know why this is there. I don't know who uses it. Somebody wanted to start up faster even when not. So let's just say ESP log tag starting safe mode, wait, and then we init boot button. Let's make sure we're doing that. This is the yellow blink that happens. Boot button pressed, that's a good complete. Done waiting. And while we're at it, we also want to know that we actually did skip user code. So let's look in main. Nice. See, like GitHub Copilot was like, oh, I bet you want to spit out that same string. Perfect. Okay, so you don't need to do a clean because we're just doing CircuitPython. And let's see if it loads. It doesn't load, which I think means that we did deep sleep. So now I had to do the boot. Can you see? You can barely see that. I had to do the boot and reset button to load it. If you're connecting after deep sleep, I'd love to see either an annoying safe 20 to 60 seconds of Wi-Fi web workflow, then monitor WebSocket, disable with an environment or nothing, no Wi-Fi. Yeah, there's no way you want to do the safe 20 to 60 seconds because like that awake period, extending it, you're using a lot of power. If you're connecting after deep sleep. I think we should auto reconnect to Wi-Fi if you have the Wi-Fi SSID and password set, but we shouldn't bother starting the HTTP server up. I think that's where I'm landing. And like, safe mode is supposed to be an escape hatch for deep sleep. Okay. So now we see starting safe mode wait, init boot button, done waiting. And then these are like debug prints we get from the IDF. They're really annoying and I've been meaning to turn off. Because like anytime we flash an LED, it causes this stuff. This is like some error with our RMT thing, but we're giving it a low timeout or something, which is why that's happening. So we can safely ignore it, I think. So, okay, let me try again. So let's see what it says now. Done waiting, init boot button. I wonder if my boot button's wrong. It does like seem to impact it some, which is weird. Oh, you know, GPIO 9 is that also NeoPixel? Is that my problem? Is that NeoPixel and the boot button are one and the same? That's possible. Where's my board def? Boards. C6 pins. NeoPixel is 9. And button is 9. Well, that's annoying. I hadn't thought about that. I don't see what Wi-Fi autoconnect gets you if it will not respond to normal things, only custom code. Custom code could boot Wi-Fi if desired, less power if not needed, but same as Wi-Fi in settings, as no Wi-Fi in settings. I think for consistency's sake, if the SSID and password are in settings, it should always auto-connect, because the code.py could rely on that. But if people don't want the behavior, they can remove the auto-connect things. And it's been on my to-do list to make sure that the web workflow would start up when you manually connect, if that makes sense. Or maybe there's a way to like manually start the web workflow too. I don't know. Okay, so our problem is that we were assuming it's two separate pins, and it's not. And I wonder if we're actually risk shorting. Do we risk shorting to ground when we drive NeoPixel signals and hold the boot button down? This is kind of a new board. Being able to start the web workflow would be what solved it all. Yeah, if you wanted manual Wi-Fi connect and manual web workflow start, maybe. If you think that's a good idea, write up an issue so I don't have to. Okay, so the problem is that we assume that the pin just stays as is. But because it's both the button and the NeoPixel, I'm curious, I don't know if, because I don't think it's actually available yet. Adafruit.com. Like I could re-init the pin every time. Although I'm surprised it's not telling me it's in use. There must be some. It should be crashing if like two things are trying to use the same pin. All right, it's getting hot in here. You know what? I'm gonna turn on the thing. Turn on the AC because it's like 81. Oh, sorry. Equally happy with auto workflow on Wi-Fi Connect. Coming soon. Okay, so that means that like the, can I open it from KiCad? Okay, so here's the, so I have access to board files before boards are released. We have like one giant repo that has all of the stuff that hasn't been released. So this is basically what you'll get. Boards are open source when they're released. So we see D9/boot comes into DI. And we see D9/boot gets grounded when you put the switch down. I'm not sure that's a good thing. If it's connected to if you hold the button down and then try to, like, if you're doing NeoPixel transmit, the problem with the C6 is that, like, it doesn't have that many pins. But D9/boot I2C power. I don't know what other pin I would use for, like, there's no free pins. So I'm not sure, like, how to fix it. Like, I think you could put a, like, a resistor of some sort to, like, not short. I mean, it didn't blow up my board, so it's not the end of the world. But that's tricky. I wonder what we can do on our end is we could, in safe mode check, we could just always make sure that we're set to being an input. So that we can read whether it's high or low. I wonder if our NeoPixel transmission is not finished. I wonder if that's part of the problem too. Well, darn, this makes it trickier. Is that because NeoPixel is still transmitting when we're... How does our code do that? Like, we could add just another board config. Was that in safe mode or was that in main? I think it's in safe mode. See, so we do construct with the boot button, switch to input, and then when we do new status color, I think that will check if it's different. I wonder if... I wonder if we're transmitting it still? Let's just see if that works. Good. We can get this fixed. I'm happy it worked. I didn't realize safe mode wasn't working. I don't know what state. I don't know what state NeoPixel leaves it in. Okay, we're in the bootloader. Oops. Wi-Fi still started up. This might be the one time that, like, oh, it did. Boot button pressed. So that did detect it. And then do we see our... There's the Wi-Fi auto startup. And in fact, these are times. We could see how long it takes. BLE startup. I feel like BLE shouldn't start on deep sleep. That might be the case. I don't actually see that error message though, of like, we're in safe mode. Did I miss it? Are we in safe mode? Can we connect to it? Yes, we can. So this says we're in safe mode. Oh, that's why. I bet we got that log now. We wait till the serial's connected to actually say that we're, because we don't want to transmit the serial message before you're actually connected. I should have made it a warning. Oh, that's annoying. Okay, well, we are in safe mode. So in code.py, let's just open it, comment it out, hit save. It won't run again because we're in safe mode. And now we should be able to hit reset, start up not in safe mode. Open code.py, save and run. It runs and it's done. I don't know why it ran twice. Okay, so we're connected to the WebSocket. Let's see what happens when we save this now. Pretending to deep sleep until alarm. Okay. So now is when I need to find another. I only have one ground pin. See if I can wake us up from pretend to deep sleep this time. Which was this one, I think. There we go. Okay, so we woken up by alarm. So pretend deep sleep works. This is, I think, what I would expect is that yeah, that's what I expect to happen. Let's play around with monitoring a pin. You think there's a board.led? True. Let's see it blink. Yep, it blinked. Okay, great. So now, what we want is, let's take this yellow one. Okay, you can't see me, so I'm gonna go, so the LED here is also connected to the what's known as D13. This is labeled by the ESP pin numbering, which I do not like, I'll be honest with you. And it looks like it needs another ground, but I don't know. Let's try it without that. Because otherwise I have to get another cable, which I can. And plug in ground. Plug it back into here. Okay. I'm going to unplug it from USB. Plug in my fake power, my fake battery. Sometimes you can backfeed over your, which is annoying. Let's see where we're at. Okay, so in here we're gonna say digital channels, just one. Let's start. Turn on power. And stop. And where'd my digital channels go? I guess this is my digital channel. I didn't ground it. That's probably my problem. The problem is I need another. I don't have that many wires. I need a female to female, or a socket to socket wire. I don't do a lot of loose wires. I have some. I just don't have them within reach. All right, let me get some more wires. Okay, so now let's do, I'm assuming that the D0 didn't work because I'm not grounding it. So I'm gonna ground it here and here. Okay. And I'm curious how long it took, but let's just do it again. Weird. 0 didn't change again. Did I have it plugged into the right place? Battery, enable. USB. I thought that was right. 4 in. And my labels backwards? Weird, it like filled it in. Blinked on. Why don't I see my blink? Do I have the wrong pin? E0. It's 4 in, I think. Maybe I broke it? Ah, tap it on 3 volts. That's a good idea. Do it manually. Here's ground. And 3 volts. Now. Down. I don't know. I guess it's not working. I'm not seeing any changes. Darn. Is there a reason? Maybe the wire's bad? That was a different one than the one I used originally. I'm not plugging in VCC? Maybe I have to do that too? Digital inputs up to 8 simultaneously. VCC to the logic port VCC, ground to the ground, digital signals to the logic. So I have to do VCC. Okay, let's try it. I'm going to make this blue wire VCC. And go here. I think that's right. And then let me connect the link. I'm used to CLEA where we only have to do ground. I think it's 4 in. Okay. Power off, power on, start. There we go. It did work now. Okay, so we see here that we now have this VREF instead of VCC for the logic pin labeled. Yeah, that would be good. Was the blink on the same pin as the boot pin? I did not. The blink is on the single color LED instead. Okay, so shift left click. So this period here, interesting, I can't, you can only select it here. It's annoying. That's pretty close. So it's 497 milliseconds. I didn't measure it exactly, but it's supposed to be half a second. So here's an idea of we're doing a time.sleep in CircuitPython, but we're still getting this pretty high. I guess the average of this area is 76 milliamps. And then you can see, I guess, how long it takes to deep sleep. So one question would be just what is all this? And one thing we could do is one thing I'm curious about is just how much of this is the Wi-Fi connection? So we can add some debug pin toggles to just show that. I'm kind of curious, so maybe we'll do that. We're just about out of time. We fixed safe mode. I wonder, we'd either add another config to do the input switch every time, or we could turn off the blink, but I think leaving the blink on is a good idea. Let's think about that. Okay, let's find the auto Wi-Fi connect. That's going to be in web workflow. Start web workflow. Here's the radio connect. One thing we could do is, like, it has to do a scan. We could assume that maybe if you're deep sleeping, it's the same. Like, we could be smarter about remembering the last channel that we connected to. Like channel 0 here, we could actually remember that, which would make our startup faster. But this is a huge rabbit hole. I think it's init. Pin 15. I think that's right. Okay, so we'll circumvent that. Clang doesn't think it'll compile. Let's see if Clang is right. Yes. So let's take a look at, we have to do the import expressive, common how. I think this is a copy. I'll just put it here. You can put your includes in the middle too. It's just bad form. No? Not that one, huh? Thought that would be it. Does that not work either? Am I just making that up? Maybe that's the... That must be what you do on RP2040. GPIO config. Set direction. Darn. That is definitely like what you could do on RP2040. Get level, set level. Okay. Web workflow. Let's just do this. Set level. It recognized it and it filled it in. And now what we can do is we can, somewhere earlier, we can initialize it. Let's do it forwards. This is all just temporary. Don't reset. No, we've got it. That's instead of a never reset. I actually want to put it in output mode. And number 15. And we're going to need not that. I think we want the driver after all. Have you tried adding comments and code for Copilot to follow up from? I haven't yet. Not really. You're seeing me mostly what I'm doing here. This is actually the thing that I want. Which I totally get is like more powerful, but I gotta start somewhere. Was the blink on the same pin as the oh yeah. Okay, so it built. We're just not plugged in. So I'm gonna disconnect that and plug in. I wonder how much quicker it would be to remember the channel. We could test it. We could have it print out what channel it's on and then. Although we're still in a debug build. And the debug build is going to be slower because of all the prints. How much slower, I'm not so sure. Okay. So I unplugged USB, plugging in my fake power again, which I left on. Let's turn it off, start, and turn it on. Oh, this is a wake from not deep sleep. So we actually also want, I don't have enough grounds. I think it's that one. Yeah. Okay, so that's a deep sleep wake. All right, so let's take a look at these two. So our deep sleep wake up period was 6.1 seconds. And if we look at our connect call here, look at that. It's like a significant chunk of it is our connect call. And if I had to guess, my guess is that these spikes are the scan. So if we just adjust this, silly. It's silly when you drag the handles, you don't get the cursor, but this is the sort of UI that I've not really done. So it's definitely the case that like turning the Wi-Fi on here is really. Okay, so it took about 4 seconds just to connect to the Wi-Fi. Now let's compare. It should be like a second different. It was what, 6 seconds total. So with this, it was 8 seconds. So we got 2 extra seconds, actually, which makes total sense because we have a 1 second wait for safe mode and we have a 1 second wait for BLE now, as of like this change that I'm working on. So this looks right. My guess is that our Wi-Fi connect time is still 3 minutes or 3 seconds. I'm just like super curious. Let's see in our debug output if we see. Interesting. NVS operation failed. Can't retrieve bonding information. Huh. I wonder why that is. I'm not planning on doing a PR straight from this. Connected. Do we see any sort of... Actually, here's timings too. 3909 is when we were connected on channel 1. So I'm just a little curious. Station start. New. See, it took a while. Like, that's 2 seconds there. But let's just hack it. And if we go into web workflow, connect, we know I'm on channel 1. So let's just see. If that speeds us up at all. Okay, so unplug from power, connect my USB. Flash. So it's 3 seconds. 3-point-something seconds. Any other questions? We got about 10 minutes left. This is good. It's working better than I expected. Like, both pretend sleep and regular sleep worked. I could split it out from the BLE stuff, too. I should add another turn on for checking out the start it up, but I don't actually want that. So turn off power. Okay, so here's the first start sequence. Ooh, that felt faster. Oh, and then that one, this one. Okay, so now let's go from here. Oops. Here. Oh, wow. It was 6 seconds, right? Now it's 3.6. So we dropped like 2 seconds off our connection time. Like, that's pretty significant. And like, how much power is that? In this area, it's like 122 millicolumns or whatever versus whatever it was last time. It's probably about a third or half. So that's a note to self of like, if we want to optimize wake up time, we should remember the channel that we connected on. Because I think what happens is that the first thing it does when you do connect is that it scans, and maybe it's only if you set channel 0, but like I think it has to scan all the channels for the SSID that you're looking for. So like, but maybe if you give it a non-zero channel, it also only looks in that channel. Something like that. Like there's like a dozen channels, so if you can tell it what channel you're on, it's going to be quicker. So that's another way to optimize if you wanted to. Does the logic trace also save to a file? Let's see. How do I save to a file? Open log file. Ah, save and export. Save session to CSV or PPK2. It says all of it. Timestamp. Single string field, separate fields. It does look like it does. Look, I even have a Salier capture folder here. So we could pipe it into SIGROC. Pronounced coulombs. Coulombs. Don't get pronunciations from the way that I say things. Can we have a CircuitPython variable for channel, then also fall back if unavailable? I think it does, but maybe not. Major risk is routers auto-optimize channels, so cannot ensure same when waking from deep sleep, although it should be. Yeah, I don't think I'm actually going to implement it right now, but it's like another, like, we should file an issue. And if, like, the thing with deep sleep and power optimization is that there's always more you can do. Like, you're never done. Just same with, like, also with execution speed. Like, you're never done, so you always got to be very wary of it. So I'm just going to change it back. Note to self, you know, there's the joke of, like, programmers leaving weights in their code. Like, note to self, we could probably save some power there if we wanted to. More like time. Like, some people complain about how long it takes to start up, and that would speed that up too. Okay, so I'm going to discard this. Oh, we didn't figure out how we want to do the safe mode fix. What was the power cost of scanning first? I don't remember. Thank you. Sorry I sneezed and didn't blink it. Okay, I'm going to discard that. I'm going to leave this BLE stuff. And we'll leave that. I think I'm just going to push this all. Actually, I don't want this. This is what I want, though, I think. WebSocket connected. And there's an equivalent for BLE as well, of like if the BLE serial is connected. Time for sure, same as the variable skip safe mode. Yeah. Not huge priorities for me. Like, we don't really care. Like, I only, like, deep sleep works great. Like, that's better than it not working at all. But to optimize it, like, we don't have a particular product that we're optimizing for currently. All right, I'm just going to stage all this and push it to my repo just to have it backed up for the day. And then I'm going to get out of here. I don't see any other questions. My goal will be, I think my goal will be to get whatever I have by the end of next week in. John, and then John in reverse says, if I could ask more of a general question, any advice for beginning a debugging development setup, programs, IDs, cables, sort of early steps beyond including print statements? So let me switch away from the overhead. I'll just switch to here. What microcontrollers are you on? Because for expressive boards, I actually just do print statements. Dan was going to try to do a JTAG, but generally I just do print debugging, even on ESP. And then if you are doing other ARM chips, I have an old but still mostly accurate Learn Guide on how to use GDB. I just use GDB with ARM with a J-Link. That's usually what I do. So this debugging the Sandy 21 with GDB is generally what I do, but kind of for all ARM chips. I still use J-Link. I'm like trying to move over to the Pico probe, so like they have pretty good docs. And Pico probes are kind of like the PPK2 of debug connectors, because the PPK2 actually, or the debug, I'll tell you, I got a second one. These Raspberry Pi debug probe things, they're $12, which I was kind of amazed by. It's just an RB2040 in here, and you can use it with OpenOCD or PyOCD. It's not quite as like get going immediately, but this, like, yeah, depending on what you're doing, like, yeah, that's a good one. I was going to ask about creating Python helpers for customized GDB debugging CircuitPython. So I haven't done any CircuitPython specific ones. The one I will point out that dovetails, I think maybe I showed it last week, this CortexMDebug thing is really helpful. It allows you to use an SVD file to print out registers. And this is implemented in Python that GDB uses. And you can't see it. Let me switch to the desktop. This bnahil PyCortexMDebug, if you're doing register, wanting to make sure that all your registers are set correctly, this is the tool for that. I do all things from the command line GDB. I don't have like integration with my editor yet, although it's kind of crossed my mind. So, John, it really depends on what microcontroller you're trying to debug on. For ESP, I just print debug. One thing I've found is that anytime that you have networking or USB going, you really do want to just do print debugging. Because if you're using a J-Link to like stop the CPU, you're going to hose all of your like network protocols and things. So print debugging really is usually what you want. If you're wanting like, you know, connectivity to continue. It's gotten really far. It's something you can apply to everything. That's kind of my take on debugging. All right, thank you everybody. This has been a great deep dive. Let me switch back to my camera. My name is Scott. I work for Adafruit. You want to support me and Adafruit, adafruit.com. Purchase some hardware there. I think we have debug probes in stock if that's interesting to you. I think I just got that one, that backup one. You can also get the Pico with headers, and it has the opposite plug for that debug thing. If you want to join the Discord, you can go to the URL adafru.it/discord. I'll be around there next week during the work week as well. I will not be streaming Deep Dive next week, but foamyguy will at the same time in my place, so thanks to foamyguy. Thanks in advance to DCD for time codes, which he's usually doing. And I'll see you all in Discord. Have a great couple weeks, and I'll see you probably in 2 weeks. I haven't thought that far ahead. Actually, that week's going to be super busy, so maybe not. If you want to stay updated, there is a Deep Divers role on Discord that I'll try to ping just with the status. If you're on Discord, ask me, and I'll add it to you, brain. Friday afternoon. I'll add you to that role if you ask me, just in case I ping to say what the status is. It's Deep Divers. With that, thank you all. We'll do a window and then get out of here. I'm going to go buy some Legos. I know that's not what you say, but I'm trolling you. I'm gonna relax with some Lego tonight, I think. Beautiful day for a walk. Thank you, everybody. Have a great weekend.